Okay, back in 7th or 8th grade, you probably learned how to find the distance between 2 points using the distance formula. But that was the distance between 2 points on a very straight line. Well, calculus allows us to find the distance between the distance along a curve. And that is called arc length. Okay. The only thing about arc length is that, and I think that this wording up here is kind of confusing, but the only thing about if you want to find the distance, like the distance along a path or the arc length, is that you have to have, it has to be along a smooth curve, as opposed to something with a cusp in it or something that is discontinuous. So basically, the function needs to be differentiable in order to find the distance of the length of the curve. And differentiable implies that it's continuous and that it's smooth. It doesn't have any sharp points. All right, so the definition of arc length is that, and they use S to represent the arc length. I'm not quite sure why they use S, but if you have a curve that's represented by f of x and you want to find the arc length or the distance between A and B, and it's not the straight line distance between A and B, it's if you were walking along that path, how far you would actually walk. Then you take the integral from A to B, and it's the square root of 1 plus the derivative of f squared dx. So pretty easy formula. So let's just jump into working example. And if your equation is in terms of y, if it's an x equals, then you would integrate from y value to y value and still use the same formula, but you take the derivative of g in terms of y. Okay, so find the arc length of the graph of y equals, is that x cubed over 6? Plus 1 over 2x on the interval between 1/2 and 2. Well, part of the formula is to find f prime of x, so that's what I always start with. So f prime of x equals, and if you wanted to, you could rewrite f of x as 1/6 x to the third plus, how would you rewrite 1 over 2x? Yeah, 1/2 x to the negative 1. That 2 is going to stay down in the bottom. So f prime is going to be 1/2 x squared minus 1/2 x to the negative 2. So you have to bring that negative 1 down. It's been a while since we've taken a derivative. Okay, so the arc length between x equals 1/2 and 2 would be the integral between 1/2 and 2 of the square root of 1 plus f prime squared. So f prime was 1/2 x squared minus 1/2 x to the negative 2, quantity squared dx. And that would probably be fairly complicated to integrate, so I would let you use your calculator. So if you have your calculators on your desk, which you probably do from the quiz, type that in. I'm not quite sure why I rounded to 4 decimals. Was it exactly 4 decimals? Yeah. Okay. So you could write that or 2.063. So the good news is that this is pretty easy. The bad news is that I've introduced another formula to you that you're going to have to know. And it's not that bad. And it's derived from the distance formula between 2 points, and that proof is in the book if you're interested in it. Okay, number 2, find the arc length of the graph y minus 1 quantity cubed equals x squared between y equals 1 and y equals 5. So because I'm interested in the distance between y values, what do you think I need to solve my equation for? X. Very good. So to solve the equation for x, I need to take the square root of both sides. So x would equal either the square root of 1 minus y minus 1 cubed, or you could think of it as y minus 1 to what power? 3 halves, good. Which I think is a little bit easier to think about. Okay, so the first thing that you have to do is take the derivative. So x prime would equal 3 halves times y minus 1 to the 1/2 power. And technically, you're used to whenever you take the derivative of y, you're used to putting in a dy, but the derivative of x would be dx, and then if you put a dy over here, then it'd be dx over dy. So it's pretty much the same thing. All right, so your arc length is going to be the integral from 1 to 5. Square root of 1 plus the quantity 3 halves y minus 1 to the 1/2 squared. And I recognize that something to the 1/2 power, when you square it, it's just going to be to the power of 1. But what else would you have to square if you're going to do that in your head? 3 halves. So you'd have to do 9/4 times y minus 1, which is fine, but just make sure that you do that. And if you type that into your calculator, you get 9.073. And that, my friends, is as hard as it gets.